Yeah, so good morning, everyone. So this is just a scene-setting talk. Over the last year or so, there's been a huge focus on trustworthy AI, and I think um, one of the big sources of that focus has been the European Commission. Um, and you'll see for example, in Europe at the moment, you'll see lots of funding programs with trustworthy AI in the title. Lots of us in the field of AI are talking about things like ethical AI, responsible AI, trustworthy AI, and I think it's an important direction for the field. And I suppose the purpose of today is to go through and look at what kinds of things we can be doing from a constraint programming point of view in this context, and are there new opportunities for doing things that we haven't previously thought about, or indeed, maybe there are things that we were doing in constraint programming many years ago that we should now dust off and bring to the fore again. So basically, I'm just going to set the scene. Obviously, it's I kind of like starting with the example of Mary Shelley's Frankenstein as an example of our lack of responsibility for the things that we do in terms of building intelligences that mimic human beings. So you're all familiar with Mary Shelley's Frankenstein. Frankenstein built a monster, but didn't take responsibility for him. Didn't show him the love and attention that he needed. And of course, we all know that it all ended in disaster. We all know how it worked out in 2001: A Space Odyssey. The AI killed the human. For those of you who haven't seen that movie, and of course, for those of you who are sci-fi fans, you probably all know that Blade Runner was set in November 2019, and these are all sort of dark stories about artificial intelligence and how artificial intelligence can go wrong. Of course, there are lots of ethical issues that we see coming to the fore now. For example, in China, there's the citizen scoring project, which is interesting from a variety of different perspectives. I suppose technically it's interesting because of the scale with which AI has been deployed. I think China are ahead of where they wanted to be in terms of the delivery of the project. Of course, on the flip side, it raises lots of ethical issues. From a European point of view, in Europe we have a Charter of Fundamental Rights, which this system would be in violation of. But of course, there are different cultures involved. But one of the interesting things here from a trustworthiness point of view is, well, as AI researchers, what should we be thinking about, and what should we be doing, and what tools should we be bringing to the table in terms of analyzing these systems? We know that there's lots of fairness issues with artificial intelligence. This is an interesting paper that was published by Facebook recently, where they looked at object recognition from different geographies. And so they took an existing data set, a very traditional ImageNet data set, and looked at they broke out the data by geographical location. And from that data, they could essentially assign images as based on the demographic of the local population, and they were able to show that the accuracy of image recognition technology was quite poor in poorer parts of the world. And so in this little image over here on the right hand side, you get a sense of what the classifications are from these various AI systems, and you see that in the traditional sort of thing you might see in the West, the descriptions are much more accurate than they are for this maybe more developing world type example. We hear of facial recognition issues all the time, and of course we have to be careful not to regard all facial recognition systems as being problematic. If you're like me, I have an iPhone. I use I use Face ID to open my phone, which I find very nice to use, and I'm quite comfortable with it. Of course, there are many other applications of facial recognition that I might not be so happy with. And of course, in these sorts of systems, then we need a way of dealing with, for example, constraints about consent, also constraints about privacy, and also we want to be able to enable our users to interrogate these systems, and we might want the systems to prove to us that certain things are true about the robustness or the reliability or the privacy or the trustworthiness of the system. And of course, many of us, I see Toby Walsh is in the room. Toby has done a huge amount of work in relation to lethal autonomous weapons and having those banned. And of course, military applications of AI in general raise all sorts of ethical issues on the one side, but I suppose there are issues of the provability of the systems, the trustworthiness of the systems, their accuracy, and these sorts of things. And so again, there are aspects of these systems that we might want to bring constraints to bear on them to get us somewhere. Of course, we've all heard of this notion of surveillance capitalism. A very famous book was published last year on all business models of around the exchange or personal data and how that's been monetized, and the sense of privacy loss here is significant, and we see on social media systems that everything up to including presidential elections can be affected by this, fake news, all these sorts of issues. Of course, then those issues of environmental well-being. This is a paper from about a year ago, where the authors show that, I'm not sure I believe the numbers necessarily, and of course these things change, but the point of this paper was to show that there are machine learning tool chains that have significant environmental impact. And the example they gave was of a natural language processing tool chain that was generating enormous amounts of carbon as a consequence of the amount of high performance computing required, GPUs and so on. As compared with, for example, the carbon footprint that we would typically have over the course of a year. So this was quite surprising data. Yes, it's changing, but it gives a sense that as AI researchers, we also might want to consider environmental issues. So there's great responsibility and trust. One of the things I've been involved in for the last couple of years is a group that the European Commission established called the Highland Group. It was basically a group of all sorts of people coming from academic backgrounds. So you see Francesca is here, Frederick Heinz is here, people from industry. There's lots of people here from Airbus, BMW, companies like that. Ethicists, philosophers, civil society organizations, to debate some of the issues around the trustworthiness of AI systems. And one of the things we produced was a document called the Ethics Guidelines for Trustworthy AI. And when we talk about trustworthy AI in the context of that document, then I suppose there are three things that we regard trustworthy AI as three principles that it must uphold. It must be lawful, so it must be consistent with whatever legal framework is in place where that AI system is being used. So, for example, in Europe, it might need to satisfy the requirements of the General Data Protection Regulation, the GDPR. It might be there might be privacy legislation in other parts of the world. It must be ethical, and so there are one can think of ethics maybe in terms of constraints and how one can impose those. And of course, it must be robust, so it must do what it's supposed to do, and provably so. And what the group did was they basically took these three properties and projected them out into 7 key requirements that AI systems should have. And so they should protect human autonomy and agency. They should be technically robust and safe. They must protect privacy and be properly governed from a data point of view. They must be transparent. So, for example, they must be able to explain themselves. They must they must not create discrimination. They must respect diversity. They must be fair. And so, obviously, for many years, people have been working on fairness, cake cutting, envy-freeness properties, and so on, using constraints and mathematical formulations. They must protect societal and environmental well-being. So, for example, take energy awareness, environmental impact into account, and they must be accountable. And so, I suppose the purpose of today is to think about, well, what kinds of things could we do? And so, obviously, these are just three particular topics we could think about. Explanation. So later today we'll have Ulrich Juncker, who will make a presentation about some of his work on explanation. And Nina will present also this afternoon and talk to us a little bit about robustness. And of course, there's all sorts of issues of bias that one might deal with. And of course, there are many, many other issues. So these are just three examples. Now, I'm not going to go through these in great details, but there's all sorts of things. So with explanation, we might want to convince users that there are things that, so why a decision was made. So for example, in this little example, why a child has been kept in hospital, and so how do we choose a good example of that? And so we might think in terms of a similar example that has some properties that make it a convincing example, a convincing explanation. And there's lots of work in the case-based reasoning community, in the machine learning community, that deals with these kinds of things. We might also, just to give you a sense of what this kind of thing can do. So imagine you're trying to explain, why this is a blood alcohol example. So we're trying to explain why this person is under the legal limit for driving, for example. And the question is, well, how could we explain that? Well, one way of explaining it is to give an example of somebody else who's also under the limit. And of course, how you choose that person is important. And so if you choose somebody who is maybe drunk more alcohol and might be smaller, and if this smaller person who's drunk far more than the person you're trying to explain, and if that person is under the limit, then that's a convincing explanation. So you're under the limit because there's somebody over here who's much smaller than you and has drunk much more than you, and this person's under the limit, therefore you're under the limit. And there's a complementary notion of this when we maybe try to explain why somebody's over the limit. So if there's someone who's much larger than you and has drunk much less than you, and they're over the limit, therefore you're over the limit as well. And so what this work is doing is looking at a kind of a notional decision boundary, and trying to find a case that's closer to the decision boundary than the case to be explained. And of course, this is something that we use all the time in constraint programming, because the decision boundary and constraints the natural decision boundary constraints is the distinction between consistent set of constraints and inconsistent sets of constraints. And so classic notions of explanation in constraint programming are things like are conflicts. So if you have an inconsistent set of constraints, you might explain that by showing that a subset of those constraints is also inconsistent. And so as you add constraints to an inconsistent set, obviously it becomes more inconsistent. It remains inconsistent. And so there's all sorts of interesting notions of explanation, like minimal conflicts, so small sets of constraints that are inconsistent, and therefore if they're inconsistent, any extension of them is inconsistent. And so this is something that the diagnosis community have been using. This is ideas that we've been using in constraint programming for quite a long time. So Ulrich will probably mention some of this later on in his example. So I won't go through the example now because we want to get a move on with the workshop. And so Ulrich has this nice algorithm called Quick Explain, a very, very famous algorithm in constraint programming for generating explanations. And that's just one possible way in which we can do this kind of thing. So also we can do things like try to automate the formulation of constraints, explain the reasoning, and maybe support querying. And so some work that one of my postdocs and I have been doing, Guillaume and I have been working on, does this kind of thing. So we look at little simple logic puzzles, and one of the capabilities we might want to bring to bear to an AI system using constraints is the ability to explain the reasoning as well as the outcome. And so that would be very interesting. Obviously, there are richer forms of explanation than just conflicts and so on. So Yuda Perl has published this very nice book, The Book of Why, where he looks at things like looking at counterfactual explanations and things like this. And so typically machine learning, the kinds of explanations you get are associations. So, what if you see this, then this also happens. And so, these are also very closely related to the kinds of explanations we get from constraints. Dominance relationships between constraints and so on. But counterfactuals, what happens if we didn't do something, if we acted differently? And counterfactual explanations are naturally expressible using constraints, and I think this is something we can maybe talk about today. So how we could imagine new forms of explanation, or more exciting and convincing types of explanation that we could use constraint programming and similar methods for. I don't want to go through this very much, but I suppose one of the things that you often hear about in AI systems when it comes to trustworthiness and responsibility and ethics is people talk about the elimination of bias. And we have to be very careful here because obviously there are situations that arise where, because of, we might be building a machine learning system and our data sets are biased. They don't contain examples that are representative of the world in which we're going to use the system. But that's quite different to biases that are, for example, racial. A system that might appear to treat one race different from the other. And this image here is from the famous COMPAS system, which is a system used in the US for making recommendations to judges on parole decisions and so on. And I suppose one interesting thing about this data set, and I'm not going to go through it in a huge amount of detail, but I just want to show you that there are different ways in which you can interpret it. So there's a lot of, you hear a lot of people commenting on the fact that the COMPAS data set is very biased, it's racially biased. And there's a reason for this. So these are the confusion matrices that you get from the COMPAS data. So basically COMPAS, what it does is it rates people as higher or lower risk for reoffense. So it's a recidivism system. And so obviously there are people who have reoffended or did not reoffend. And what it's trying to do is predict whether people are at higher risk or lower risk for doing so. And people typically analyze these by breaking out, for example, different races, whites from African Americans, for example. And one of the reasons why people think that this is biased is that if you look at who the system regards as high risk, COMPAS regards African Americans as about 60% of our African Americans as high risk, whereas about 35% of whites. And this is something that that most people would regard as would be uncomfortable with, because it suggests that the system is racially biased against African Americans. And I suppose this certainly looks like there's a problem. If you look at, for example, those who are rearrested, you do see that that in the populations, the rearrest rates are quite similar to the prediction rates of who is higher or lower risk. So, for example, COMPAS believes it rates 60% of African Americans it considers as higher risk, and 53% of them went ahead and reoffended, versus 35% predicted for whites and 39% who were rearrested. If you look at things like false positive rate. So this is people that are believed to be higher risk but are not. Again, we see that it looks like there is significant racial bias, because the African Americans are significantly disadvantaged, almost by a factor of 2, when one looks at the false positive rate. When one looks at the false negative rate, we get a similar form of bias. We see that this is the kind of Ted Bundy impact, the people who are believed to be innocent but are not. And far fewer African Americans, again, almost half as many as compared to whites, are considered to be innocent when they are not. So the white population is getting that benefit. But I suppose one question is whether comparing the data in this way is interesting or not, is useful. And there's a bias measure called calibration, which basically measures to what extent each population is calibrated for that population. And so, for example, of the number of people who are considered higher risk, 2,174 in the case of the African Americans, about 1,400 reoffended. In the white case, about 854 people were considered to be high risk, of which about 500 reoffended. And these values are roughly the same. And so it suggests that that disparity we saw earlier, from a calibration point of view, isn't there. So it seems this data set seems to be free of calibration bias, but it has these other biases. It has this false negative bias. It has this false positive bias, and so on. And so the question is which form of bias is correct. And of course, if we were to think about, for example, recruitment, we might this is a bias that we might want to promote. We might want to promote the fact that there is a positive bias towards females versus then males. And what's interesting is that you can't eliminate many of these biases. In fact, there's a famous theorem by John Kleinberg that basically says that it's impossible to have calibration bias, to have both calibration and equal false positive and false negative rates, unless the world is already fundamentally equal. Now you might say, well, what's this got to do with constraints? Well, one of the interesting things to do with constraints is that we might want to think about how we might be able to build machine learning systems by placing constraints on the confusion matrices that are produced by those systems. And so it's interesting to think about ways in which you could build. So typically, when we look at confusion matrices, these are an output of a machine learning system. They basically tell us how it performs. But we might actually want to try to constrain the kind of bias that the system exhibits using constraints, which might require that we build a machine learning system using constraints. And so we could build essentially machine learning systems that have high accuracy, but satisfy certain bias constraints that we might want to impose. So some of you who watch this kind of thing are probably aware of the notion of adversarial examples. So these are examples that machine learning systems can be presented with that are misclassified with high accuracy. And this is these are seen as a major challenge in the robustness of machine learning systems. So this is a famous example over here that many of you are probably aware of, where a commercially available autonomous vehicle misclassified these stop signs with high accuracy as 45-mile-an-hour speed limits. And the adversarial examples were created by somebody carefully placing black and white tape on these stop signs to corrupt the example. And by doing so, the stop signs were completely misclassified. And there are lots of other examples that you come across in the literature of images that have been modified in very subtle ways and are misclassified with high accuracy. So, for example, here's a gray fox, here's a macaw. Clearly, they are not, but the AI system that's classifying these images has high has high confidence that they are what they say they are, and that's interesting. And of course, there are people who have used constraints to formulate adversarial examples. So this is there's some work by Khalil and others where they basically frame the problem of constructing adversarial examples as an optimization problem. And this is a way of in a sense, measuring the robustness of a system. So what do those adversarial examples look like? So these can be formulated as in this case, as a mixed integer program. There's other work by Nina and others, and Toby, for example, who's on the call, where they look at proving properties of deep neural networks, I suppose specifically binarized deep neural networks, so that certain properties can be proven. So to what extent can these systems, are these systems robust to adversarial examples, maybe proving that systems are equivalent, proving that one system, that systems have various other properties one could imagine. And so this is interesting because, again, we can bring constraints to bear, in this case, Boolean satisfiability, to bear on these things, which is very, very interesting. So I suppose for me on Trustworthy AI, one of the opportunities that we have as a community is that obviously between the deep learning and the automated reasoning community, in the sense of the two extremes of AI, I think there's a great opportunity for constraint programming, for logic, for Boolean satisfiability, for these formalisms. And the purpose of today is, I suppose, to talk about those, to reflect on them. This afternoon, we will begin to work together on a white paper that might set out ways in which we see constraint programming benefiting and supporting trustworthy AI, the building of trustworthy AI systems. So in what ways can we use constraints for dealing with bias, for dealing with robustness, for dealing with explanation? That would be great. I'm going to just take the opportunity before we finish to advertise a new centre that we have in Cork, the Centre for Research Training in AI. If you have any PhD, if you have any students who want to do a PhD, we have lots of funding now for PhD students. We have funding, in fact, for 120 PhD students over the next 4 years. If you're involved in centres that produce PhD graduates and you'd like to set up collaborations and exchanges, we'd be delighted for that too. You can find the website down here. We'd be delighted to talk to you. With that, I'll hand you back to Begum, and we can go on to the next session. Or I'm happy to answer questions, actually, if anybody has any questions.